All right, plan today is to do the calculated multiple choice first, and with time permitting, we'll jump into free responses, and we'll get as far as we can with that. On the calculator part, there were 6, maybe 7 questions that required a calculator. The rest of them you'd have been able to do without it. You'll need exams.
I like the part where a 3 is only like comparatively, what is it, 10, 12 points, but and 5 is like from 67 to 108, so it's over like 40 points.
They have a pretty good idea where the zone is gonna fall, like the kids are gonna do this, that, and the other. And they basically start with mastery, the 3, and then kind of space it from there. There really aren't that many people when you get a 5 that just barely make a 5. You tend to fall well above the 5 range. And the 1s, the most common score is a 1. That one has a little over 50%, like 52, 53% of the kids get a 1. Then 5 is the second highest usually. Then 3, and then 2 and 4 tend to be your lowest ones. So kids either, they land in the zone in the middle where they expect the kids to fall, or they go to one of the extremes. There aren't that many in the gray area of 2 to 4. 2 and 4, excuse me. Okay, let's start with the calculated multiple guess. That's number 76. If I remember flipping through these, this is less computational. This is more thinking on this part of it. All right, for 76, we got the graph of f shown above. For which of the following values of x is f prime positive and increasing? Okay, let's talk about that. F prime positive and increasing. What does f prime positive mean about the original function f? If f prime is positive,
If f prime is positive, then it's going up.
then the original function f was going up. That means f going up, okay? What about f prime increasing? That was a tricky part.
That means it's going up, but it's increasing, like it's curving up, like
It's concave. Good, yeah. F prime increasing means f double prime was positive, which also means f was concave up. This is how, in 5 seconds, all that stuff should just tumble into place in your head. So what we're looking for is a place where the original f is both heading up and concave up. All right, at A, we are decreasing and concave down. At B, we're undefined in all regards. C, we are increasing, but we're concave down. D, we are decreasing but concave up. And E is the only one where we are increasing and concave up. So E on that one. 77. How many of you got that one right? 76. Did y'all interpret it that way? Is that how you thought of it? 77, let f be the function that is continuous on the closed interval from 2 to 4 with f of 210 and f of 420. Which of the following is guaranteed by the intermediate value theorem? All right, do you remember your intermediate value theorem?
No.
Let's review that. Okay, 2 things have to be, actually, 1 thing. In order for you to do the intermediate value theorem, the first thing that has to be true is that your function f is continuous. Okay? If it is not continuous, an intermediate value theorem falls apart. Here's what the intermediate value theorem says in a nutshell. If you have point A and point B, so this would be the point A, f of A, and this would be the point B, f of B. Okay? Now, intermediate value theorem says, if it is continuous, meaning I can get from point A to point B without picking my pencil up, then I attain every single value between here and here.
Yes.
Okay, I hit every y value between there, at least once, they don't tell you how many times, at least once. I may go outside the zone, I may go a little too high or a little too low, but I can guarantee you that I'm gonna hit every single y value from here to here, okay?
It's kind of obvious, but I mean, like,
Well, it is, and it's important, it seems like an obvious theorem, but I've seen many kids in recent years trip up because, yeah, it's obvious, but they don't word it the right way on the AP test. This is what they forget. You can't use intermediate value theorem unless it is continuous. If this were a step function, can't use intermediate value theorem because it's broken in between there. You can have cusps, all right? I can do a little jagged thing in between there, but I'm gonna hit every single y value in between. Some people get this one mixed up with mean value theorem, which says I have to be both continuous and differentiable. A little extra bonus in there. So knowing that some function f is continuous, they tell you that, from 2 to 4, but f of 2 is 10 and f of 4 is 20, which of the following is guaranteed? That f of x equals 13 has at least one solution between 2 and 4. What do you think? F of x equals 13 at least once in between there.
Yes.
Yes. Why?
because it's in between,
Because 13 is in between
Oh, 10 and
10
20.
and 20. There you go.
That's it?
Done.
Okay.
What about f of 3 equals 15? 15 is in between 10 and 20.
oh, actually, it's,
Oh. Yeah. Why isn't B right then?
Cause it's not in the interval, it can be before f, I mean, f of 2, it can be 4, 2, after.
No, it actually has to be somewhere in between 2 and 4, but it doesn't necessarily have to be at 3.
Oh,
You get that? We could have hit 15 at 3.9 and then just shot up to 20. We don't know that. F attains a maximum on the open interval from 2 to 4. Maxes and mins. Now we're talking mean value theorem, not the right one. F prime of x equals 5 has at least one solution. That, again, is mean value theorem. And f prime of x is positive for all x's. Not necessarily true. Could have done this to get there. No big deal. It's that first one right off the bat. And as soon as you see it, mark it, move on with life. 78, the graph of that crosses the x-axis at one point on the open interval from 0 to 1. What is the slope of the graph at this point? All right, here is calculator heavy question number 1.
Okay.
see,
I forgot how to use the calculator for this one.
Okay. So,
I should grab
we don't have a projector. Yeah, I'll get you some. We don't have a projector, so y'all may want to practice this just to make sure you got it. Where is my 5th calculator?
Oh, I have it.
Yeah.
It's in my book bag.
Yeah, okay. Which is not here?
No. It's in my car.
Gotcha.
I should have grabbed it while I was out there. I was out there this morning.
Do you need to practice with it? You good?
this was just fine.
Okay, what is the first thing I would have done with my calculator? So this is the very first super calculator heavy. What would you have done first?
Graph.
Graph.
Graph it. Good. So step 1, graph.
Step 1, hit the right button.
Yeah, turn it on. And y equals. Ooh, I'm in the wrong mode. Okay, sure. Clear that. So I'm gonna do E2, and I hope y'all know where these buttons are by now. Tangent X.
I do, but I still hit the wrong button.
Do make sure that you're getting back to the ground floor before you hit -2. So the -2 is not part of the power. I would also crop off my window here to the 0 to 1 thing and just see what that is. So I'm gonna pick the windows, do from 0 to 1. Count however you want to. The Y's, I don't know and I don't really care. Just enough to see it. Okay, I did my y's from -0.5 to +0.5, and then my x's went from 0 to 1, just so I saw the only part of this graph they really cared about. Okay, so step 1, graph. Step 2, find the root. Do we know where that button is?
Yes.
Okay, so I will hit second, calculate. Listen carefully if you don't know how to do this. Second, calculate a 0. Go somewhere to the left of that 0, anywhere is fine. Somewhere to the right of that 0, anywhere is fine. And then guess, and it tells me 0.6061193. 0.6061193. And there is more, but we'll use as much as we can. All right, now what?
I just put that down.
Do it.
That was one of the choices.
Ah, yes, because
So-
that is where the that's where we have a root, but they didn't ask that. They said, what
Yeah.
is the slope of the graph at this point? So then what do they, try that again, what do they want me to do?
Derivative.
Good, now I'm going back to the home screen, and I'm gonna do math 8, which is a derivative of, and I'm gonna type that function in, e to the tangent of x minus 2 at 0.6061193. Put as much crap there as you want to. And I'm gonna hit enter. Man, that calculator is fast. Alright, then we're gonna go take a derivative with math 3. I'm sorry, math 8. And we get a slope at, or of, not at, of 2.961. D.
What's the derivative of tangent?
Secant squared.
Okay.
Made me think about that one, yeah. By the way,
Okay.
if you're doing this one by hand, that one might trip you up. This one, just plug it into the calculator and it should give you
That's what
the-
I did it by hand, and I think because we don't have there's no secant button, but I think I did 1 over
cosine.
1 over
Right.
cosine squared, but I don't think that worked well. Or I did it and it messed up somewhere.
If you do 1 over parentheses cosine blah 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 squared, that would
It
actually
might
be
mess
fine. Yeah.
Oh,
But it's
that whole
E2
thing
though.
squared? Oh, I thought it was 1 over cosine squared.
It is the cosine squared, but you can square the 1, it doesn't really matter. But it is 1 over cosine squared. The thing is, it's not just that. It's e
To
to the tangent
the,
x,
yes.
and then divided by
Yeah.
cosine squared or times secant squared. Yeah.
I thought it was
2 gets washed out. And then whatever you get for this slope, was it D? Is that right? D for this one?
Yeah.
Point, or 2.961.
I was up somewhere.
So those of you that said A, you at least knew this was a calculator question. You graphed it, you found the root correctly, but then we need to go one step further and actually read to
I
take
would
a
hope this was
derivative.
quite calculated question with all these decimals.
That's kind of a dead giveaway too. When I see a bunch of stuff like that, I'm thinking, yeah, punch it in. 79 does not look like a calculator question. A particle moves along the x-axis. The velocity of the particle at any time t is given by v of t. And the acceleration of the particle is given by a of t. Which of the following gives the average velocity of the particle from 0 to 8? Oh my word, thank you! What is the right answer then, children?
B.
Okay,
I thought right. Yeah. It's kind of easy.
for bonus points, what is A?
A is the slope of that at that point.
No,
Oh,
slope of what?
Slope of it's the average slope.
Slope of the acceleration,
Acceleration. Oh,
which, yeah. B is our right answer. What is C?
What's it? No.
Which is the absolute value of whatever your
Oh, yeah, it's
answer for B
absolute.
was.
Which we didn't want that. We wanted the
Which,
total.
yeah, if our answer for B is negative, we actually want it to be negative if we're doing average value. What is D?
D is half.
D isn't anything.
D is like if you want to take the average, but you messed up on the average. Like
D doesn't even have any meaning in calculus at all. That's, I'll take that back. Yeah, it doesn't, nothing. That's not a formula we've ever done. And then E is, what? These are crazy, that's stupid. Thank you for getting P and moving on with life.
I guess the only trip over was B and C,
I have no
and
clue.
if they wanted all.
A honestly would have been an appropriate second wrong answer because it is the closest to what's actually happening, but that's not right. All right, 80. Again, look Ma, no writing. The graph of f prime, the derivative of the function f is shown above. Which of the following statements must be true? Okay, this is f prime. Man, y'all have a hard time reading the graph. Let me try and recreate this one so we can talk about it. So you have, notice they didn't put a y scale on it, they have put an x scale, not a y, so we don't really know exactly how high it's going, and we don't really care. There, let me go somewhere up here, and then add -3, is that right?
Mhm.
3. All right, so I need to do, and it's somewhere in between, let's say about here. We'll do something like this. And then we do something like this. Hit that somewhere. Okay, so crude sketch, there we go. This is f prime. All right, let's see what you want to know. F has a relative minimum at x equals -3. Now, the question they're asking me is about f. This is a picture of f prime, they're asking me about f. How do we find where f has maxes and mins?
When it's 0. And when it goes from.
Don't ever use the word yet.
When f of x goes from negative to positive.
No. When f
F prime.
prime of x goes from negative to positive, okay? And we would have a max where f prime goes from positive to negative. So this point right here is where f has a max. And this point right here is where f has a min. Okay? What would this point be for f?
That would be when it goes from concave up to down.
Very good. Because f prime is increasing up to that point. This is where f would change concavity. This side would be up. This side would be concave down. Good. Looks like it wanted to do it here. It was thinking about it. It's like, no. So it quit. It didn't quite change concavity at that point. F has a relative minimum at x equals -3. True or false? I'm
you
sorry.
mixed those,
I
yeah.
got those backwards. Thank you. Just erase that part of the table. We're not pointing at the board. We're off a little.
Well, it moved itself.
I think Graham moved it.
God, but grandma can't be her fault.
There we go. All right. Thanks for joining us again. All right. Let's see. The graph of f has a point of inflection at x equals -2.
No.
It wanted to.
It tried.
It tried, but it didn't. The graph of f is concave down from 0 to 4.
Yeah.
Yes. All right, so 1 and 3,
Mhm.
E. There we go. Good one. Did I get that one right?
I've got the first one wrong.
No. You getting teary-eyed?
Yeah, I'm about to cry.
Is my eye red?
Yeah. I get misty when I think about math too. 81. Water is pumped into a tank at a woo, the old water in the tank trick.
Oh.
All right, gallons per minute, where T is the number of minutes since the pump was turned on. If the tank contained 800 gallons of water when the pump was turned on, how much water to the nearest gallon is in the tank after 20 minutes? Holy crap, thanks for my points. So how am I gonna figure out, let's see, that's a rate. So in order to get from a rate to an actual amount, the gallons, I'm gonna take an antiderivative. So I'm gonna do the antiderivative from 0 to 20, because they're doing the 20 minutes, of R of T. So I'm gonna type all that mess into my calculator and see what I get. Again, to practice, just to make sure I know how to do this. This is the second calculator question. Let's see here, math 9. Gonna go from 0 to 20 of R of T, which was given to me as 30 times 1 minus e to the negative 0.16 x. Close that parentheses off, dx. And my answer is 250.597. So what do they want, to the nearest gallon?
Yes. Then you probably have the,
Make sure it's, oh, I did not type that in. I did 0.06, not 0.16. Let's do that again. Typing in the correct stuff. There we go. All right, so I get 420, wow, that's a big difference for a 0.1. 420.14, so 420.
420.
So why isn't B the right answer?
Because you have to add the answer.
Very good, and you know people are gonna put B down because they didn't add in the 800 original gallons. So if we add in the 800 that we started with, we get 1220 for a right answer of D. All right, feeling good? Y'all just stop me if you need to talk more about it.
20.
Y'all just stop me if you need to talk more about it.
I put B. I got a different
Which one's it? What's this say?
answer. 21, I put C.
For 81, you would say?
Yeah, 81.
I'm sorry. Right answer is D, correct?
Yes.
Okay, and y'all check me, make sure I'm not doing these wrong. I'm not, but. Ooh. If F prime is equal to that garbage, then F has a local maximum at. Kidding me? All right, look at the numbers. This one's calculator. What do they want you to do?
Graph.
Okay.
They want you to graph it, correct. Now, you could do that. You could take all these answers and plug them in to see which
Oh, no,
one
that's not
gives
that.
you zero.
I got really graphic.
Yeah, so I would go over to the y equals and I would graph that. And, okay, when I'm thinking of a window to use, look at the answers they've given you. It goes from about negative 2.3 to about 1.24, something like that.
Just put it from
Put it from like negative 3 to 2. Okay, make sure I'm not gonna screw up this typing in. So we have square root of x to the 4th plus 1, that's all inside one square root, and then make sure you get out of the square root, plus x cubed minus 3x, and then I will size my window to accommodate this. I'm gonna go from negative 3 to about 2, doesn't really matter how you count those. And my y's, I honestly don't care about too much of the y value, I just need to see where I'm changing from positive to negative. So like negative 1, 1. All right, so when I graph that, okay, a local maximum,
So,
which means I need to be changing from the F prime has to go from positive to negative. The only place that happens, it looks like it's just shy of
you probably zeroed it out to me.
a half. So I'm gonna go with about point.
Good point. There's too close to it.
I'm gonna guess the 0.350, but because that one's slightly less than a half. So I'm gonna confirm it. I'm gonna find a root there. Just
Can't
make
I
sure.
ball it on the AP?
Well, you could. Honestly, that one's the only one that, within the confines of these numbers here, that's the only one that makes any kind of sense.
1.8's pretty close too.
But it's over a half. In my picture, I have it, that's my half mark right there. We'll take mark and it's under a half, so there you go, 0.350. C, again, this one was calculator heavy. Had to have it. This one is calculator heavy. Again, just graph it and figure out where you have, what did I say, C, is that our answer?
Yeah.
Okay, flipping over, 83. The graph above gives velocity of a car where okay, cool, velocity. Time is in seconds. Of the following, which is the best estimate of the distance traveled by the car from 0 to when it comes to a complete stop? What do they want you to do? Here's a better question. How do we go, if I give you velocity, how do you tell me distance traveled?
Into
Antiderivative, from point A to point B, right? So this is what I'm thinking, is antiderivative. There's a tiny, tiny problem with that. What's the tiny problem with taking the antiderivative?
we don't know what the truth is.
We don't have the function, okay? So we need to drop back and punt. Antiderivative, you know, I just distinctly remember another application of the antiderivative.
Here,
Area. Ah, that's all you wanted me to do was find the area. And they've given you all these nice little squares to count up.
where did I
so-
put it? Dang it! I was 5 off.
Count squares,
No, I did.
okay, because it's area.
I can't correlate them.
All right, let's see here. I got, in the first column, 1, 2, 3, 4, we'll call it 5.
Yeah, that's pretty much a little.
1, 2, 3, 4,
If you count the second, those two, probably from the third row.
yeah, that's a good
Oh,
idea. It could be. Yeah,
What-
let's
what
count
that-
up whole squares first, let's do this.
1, 2,
5, 6, 7, 8,
4.
9, 10, 11, 12, 13, 14, 15, 16, then we get into the gray area. Let's start adding.
16.
I got whole ones, but it's kind of hard to pick which half ones we're gonna put together.
This one.
5, call that 10, 11, 12, 13, 14, 15, 16, 17-ish, 18, 19-ish, 20, I guess 21-ish.
I got 26s, but that's 3 weeks.
I got 21-ish. Oh, it's counting by tens though. So each of these blocks are not, so multiplied by 10, so 2 10-ish, is that right? Is the right answer D?
I think that these two are the most common, like if you miscounted and then like they had like, if you got 21.
If you went like whole squares at a time or something, or too low?
Or you just went, yeah, you just went like too low, you probably.
Oh yeah, 21, I see, yeah.
There's 21, 26, and then there's this random number, 8, 21, 80, which probably, I guess.
Notice how far apart the guesses are. That, you know,
They're not
18 to, they're not that close together, so they expect you to be able to, yeah, it's kind of in that ballpark. So D for that one, is that our guess?
Yeah. That's the answer.
It is the right answer?
Yeah,
All right,
that's
so
right.
we
I didn't get
counted
that.
it pretty well. Did you at least understand the concept?
I
should
counted,
be
I
counting
counted,
squares.
I just messed up and
Okay.
counted 4 extra.
Okay, I hope y'all can count squares on the AP test, that would be nice.
I counted
Oh, I got this one right.
Good. 83 or 84?
83.
Okay, I'm pleased. Defensive, you're like, I got one right, I can do that.
I did.
I can count.
Oh, seriously, this was easy. Okay, 84, for the interval from negative 1.5 to
So easy, you do it.
1.5.
So it's so easy, you do it.
Okay. Let f be the function with the first derivative given as such. Which of the following are all intervals on which the graph of f is concave down?
Take it away.
Take a derivative. So what I'm going to do is take a derivative,
Say equals 0.
graph it.
Okay.
I mean, look at all these decimal points. Yeah, that's what I'm doing. Okay, so I'm gonna take a derivative and graph it. I'm gonna do the derivative in my head. It will be e to the crap. Okay, so
E to
you
the
got,
crap times.
the 2's gonna wash out, and then times the derivative of the other mess, which is your 4x cubed, and so on and so forth. All right, so e to the x to the 4th
Minus 2x.
is 2x squared plus 1, and then I will multiply that by the derivative, which is going to be 4x cubed.
You forgot the most.
You want me to wash this out?
Minus 4x, and then the 1 is gone, and then the 2 from the outside is gone. I'm gonna go ahead and set my window at negative 1.5 to 1.5. Maybe count that by 5s. And my y's, I honestly don't really care that much, because I just need to see the windows there.
Negative 1
Okay, concave down.
to 1. So it was, if where it's concave down would be where it's negative.
Good, so I'm thinking, looking at my picture, if you graph this, there's a little chunk of graph that's negative to start with, and it loops up and does a big positive, and then it's got this down loop. So I'm thinking, let's find the first intersection point, which is over here to the left. Keep tabs on this for me. Alright, so I get, our first one is going to be from negative 1.5 to negative 1. Oh, there we go, there's our answer.
What?
Because D is the only one that goes from negative 1.5 to 1.
Yeah.
And my second one is going to go from 0 to something else. It appears to be 1. By the way, you could do this one by hand.
You see the other ones might be if you didn't plug it in.
Well, look at your derivative, watch this. Some of y'all looked at this and kind of, I'm not gonna say freaked out, but look at the second derivative and then tell me why this one's a by hand kind of problem. We had e to the x to the fourth minus 2x squared plus 1 times 4x cubed minus 4x. All right, if I set that equal to 0, there's a really big part of this graph that does not, or this equation that does not matter.
Either one side, I mean, one side doesn't exist or the other side doesn't exist.
Okay, correct. So when does this equal 0?
When,
Exponential functions never equal 0.
okay, so, bam.
So not necessary. This one basically solves itself. Pull out a 4x, you get x squared plus, minus 1. So we get 0, 1, and negative 1. So there are your critical numbers.
No, that's why, 1, 0, and 1.
So this was that gray area. This is the one, we've had 3 calculator heavy, and then 1 meh, if you wanted to, or you could have faked it without it. Right answer was D.
C. I mean, yeah, D as in,
Oh,
C.
C. S-I-C.
yeah, not C as in C, cap.
That was for you, Edward. C.
Got you, buddy.
The graph of f prime, the derivative of f, is shown in the figure above. The function f has a local maximum. Man, how many times do I have to answer these correctly before you get that I can do it? Where do we have a max?
Easy. Oh, you want the answer?
Yeah, I would like the answer. Don't look at your answer choices.
It's, I didn't want to get it wrong. C.
Yeah, it's at 1 because this graph goes from positive to negative, which is where we have a max at 1. And remember, this is f prime, and they're asking you something about f's, maxes, and min. This is a yawn fest. By this point, I've answered this question so many times, you should get the idea. Okay? 86. Ooh. If f prime is greater than 0, so f prime positive, got it, for all numbers x,
I guess on this one.
by the way, we can narrow down part of it. What does it mean if f prime is positive?
And that means that if f prime is positive,
What does that mean about the original function f?
it was going up.
It was going up.
Yeah.
So let's see if we can't narrow down any of these. A has numbers that are going up, B has numbers that are going up, C does not. 6 to 3 is a drop, so you're out. D is out,
And then he's there.
and E is there, so C and D are out. And the antiderivative from 4 to 7 is 0.
Which means it's. Oh, it's both. It's
Ooh.
both.
That's awesome. What does that mean? It
That the area
canceled out.
canceled out. Yeah.
Which means we had to have some value that was negative and some value that was positive. And if I'm increasing, that means I need to go from negative to positive.
Okay.
So A is out because it stops at 0, and E is out because it's all positive, so my answer is B.
I didn't know.